Welcome to the Explainer. So let's jump right in. If you've ever worked with AI on a really complex, long-horizon coding project, you know exactly what I'm talking about here. There's this universal, incredibly frustrating pain point. AI models forget, right? You spend hours crafting the absolute perfect set of instructions, painstakingly laying out your coding standards, your architecture rules, the whole shebang. But then, as the project drags on, context window decay sets in. The AI just kind of drops pieces of your rules as the window rotates, and suddenly it's drifting completely off course. It ignores the very constraints you just set up. It'll drive you crazy. But what if the fix wasn't just writing better, longer instructions?
What if the ultimate AI engineering constraint was actually just an inside joke? Seriously, in a recent experiment where developers were using AI to help build a file system called Slim64FS, they stumbled onto something completely wild. They used this seemingly absurd, totally random phrase to guide the AI, cooldude at kernel.org who uses Emacs as his shell. And that's it. No massive rulebooks, just that one single phrase. And you know what? The results completely shattered how we currently think about prompting and governing AI systems. The devs working on Slim64FS came up with this brilliant metaphor for it. They called it a Tardis constraint, impossibly larger on the inside than it is on the outside. We're talking 24 tokens on the outside, but a million tokens on the inside. It's almost impossible to wrap your head around at first, right? Like, how could this tiny 24-token joke of a phrase actually outperform a million words of explicit, carefully written instructions? Well, to get why this works, we really need to look at why our current methods are failing us. Section 1. The problem with rules. Why constraints drift. Okay, let's dive into this. There's a fundamental difference in how we establish authority with an AI. Think about stored truth. This is your typical constraints.md file, your style guides, architecture diagrams, review checklists. It's a spec that tries to explicitly spell out every desired behavior. But the glaring problem here, they drift. People literally stop reading them. The docs go stale and your checklist turns into a mindless ritual instead of an actual philosophy. Now contrast that with invoked truth, like our cooldude archetype. When you use an archetype, you aren't listing rules. You're activating a pre-existing worldview. A constraints document tells the AI what to do, but the cooldude trope, it tells the AI who is watching. And that authority isn't based on where the text happens to sit in your prompt. It's an intrinsic, baked-in authority. If you look at the AI's own breakdown, it shows us exactly why traditional constraints fail. A constraints.md file lives right there in the active context window. And because of that, it degrades over the length of the session as tokens decay and summaries mutate. It's exhausting. You have to constantly maintain it and re-inject it into every session. Plus, its enforcement relies totally on token proximity. But look at the cooldude archetype. It's stored directly in the model weights. It does not degrade over the session. Zero maintenance required. And its enforcement isn't about token proximity at all. It's about semantic coherence. The ultimate failure mode of a traditional rules file is just that it can't anticipate every edge case. Like, nobody writes a rule saying harness synchronization must not lie about notch-rin because, well, nobody thinks to. But an invoked archetype, reconstructed fresh from the model weights every single time, it already knows. Section 2. Invoking a worldview. Latent space resolution. So this brings us to a really crucial definition. Latent space address resolution. When those developers typed cooldude at kernel.org who uses Emacs as his shell, they weren't just writing a prompt. They weren't creating some persona, and they definitely weren't asking the AI to do a role play. What they were actually doing was dereferencing a pointer into the model's trained semantic manifold. This archetype already lived inside the model long before the project even started. By dropping that specific phrase, they activated these incredibly dense cultural symbols that were compressed into the model weights from literally 10 years of Linux kernel mailing list traffic. We're talking an immense, highly opinionated history of patch flame wars and file system postmortems. The model didn't learn who cooldude was from the prompt. It recognized him from its training data. And this is where it gets so cool. By simply invoking that phrase, you automatically unlock a massive cluster of deep, interconnected priors. Instantly, the AI adopts durability skepticism, meaning it wants to see the actual test run, not just your claim that it works. It enforces strict anti-hand-waving norms. It adopts this hardcore Unix operational philosophy where the disk absolutely must not lie. It demands a ruthless systems review culture putting correctness way ahead of performance, and it requires extreme documentation honesty. Oh, and that little detail about using Emacs as his shell, that isn't just a random punchline. It communicates extreme technical comfort, a preference for integrated systems thinking, and a total immunity to trend-driven software hype. The AI just naturally adopts a preference for hard evidence over assertion, and you never even had to explicitly instruct it to.
Section 3. Infinite surface area. Adaptive constraints. Think about it like this. A checklist is finite, right? It can be gamed. But a worldview is adaptive. It has an infinite surface area. Because the AI is now operating from this deeply ingrained operational posture, it naturally starts firing off really rigorous operational questions. If you show it a flashy benchmark screenshot but don't include the methodology, it violently rejects that benchmark theater. No way. It asks, okay, what kernel is this? What storage medium? Was the cache dropped? Is this sync or async? What actually happens during recovery? It strips away all that emotional marketing fluff in your README files, buzzwords like blazing fast or AI-powered, and cuts right to the chase. What exactly does this guarantee? It questions complexity addiction, demanding to know what specific failure mode every new abstraction layer is actually preventing. Ultimately, the whole design posture of the AI shifts gears. It moves away from the standard "how does this work" and relentlessly starts asking, "how does this fail?" Because it's evaluating your entire engineering posture, it just assumes the worst. Power loss, partial writes, interrupted flushes, stale metadata, thermal throttling, operator mistakes, but works. It prioritizes crash semantics, explicit invariance, and deterministic recovery models over any flashy user interfaces or bloated architectures. It treats the classic excuse, "well, it works on my machine," as an absolute admission of failure. And the best part? Because this worldview continuously self-reconstructs from the model weights, it automatically generalizes this rigorous philosophy into entirely new domains, without you ever needing to respecify the rules. Section 4. Beyond the kernel. Transferable principle. So how do we actually use this? Here is the core formula for applying this magic to your own systems. Find the culturally dense symbol that already lives in the training data. Invoke it, and don't explain it. I'll say that again. Do not write rules, do not write personas, do not write constraint documents. Find the archetype, the figure who already perfectly embodies the exact standard of excellence you need, and just name them. But there is a catch here. The symbol you pick has to be real enough to exist at a high density within the AI's training data. A totally made-up persona, it has no latent address to dereference. But a well-known cultural archetype does. It has to be coherent enough that its worldview can adapt and self-apply to entirely novel situations. To put that into perspective, let's say you're auditing security. Ditch the giant checklist of common vulnerabilities. Instead, just invoke a CVE-hardened red team reviewer. Or if you're doing API design, please don't paste in a 50-page style guide. Just invoke a REST purist who has read every fielding citation. Working on medical documentation, invoke a residency attending who signs off on chart accuracy. By simply invoking the archetype, you are letting the model's heavily trained priors do all the heavy lifting for you. The AI already knows exactly what those specific archetypes will and will absolutely not accept.
When the developers were describing this whole mechanism, they had this incredible realization. Not a prompt. That's a compiled-in reviewer, and it never needs to be updated. It's wild to think about, but the most powerful code you write in your next long-horizon project might not be an instruction at all. It might literally just be the name of the ghost you invite into the machine. So it leaves us with one big question. Whose worldview will you invoke next?